Cool. Yeah, so tonight I'm presenting a brief history of Jupyter Notebooks. And I guess the inspiration for this talk was my observation that in some ways it seems like there's really two different worlds of Python developers. There's some Python developers for whom writing Python looks like this, and there's other Python developers for whom writing Python looks something like this. And as someone who has found myself kind of with a foot in both worlds, I thought it would be interesting to try to dive into a little bit more about this tool, the Jupyter Notebook. And you can also see that I've managed to follow the standard convention of Jupyter Notebook naming with that notebook called Untitled One. Um, so recognizing that there are two different kind of worlds, and maybe not everyone is so familiar with the Jupyter Notebook, I want to start off the talk just grounding us in and what I'm going to be talking about this tool. So I have this video of myself doing some things that you can do in a notebook. So you can execute Python code, a hello world. You can do basic addition. And the other interesting thing you can do with the notebook is you can also put in Markdown type cells. So that's another common feature. And so you can start to see that the notebook is useful not only for executing code, but also starting to put in text around the code. And that's obviously a big component of it. So this is a small snapshot of a Jupyter notebook, just so that everyone is kind of on the same page about the tool we're going to be talking about. And you might ask, well, why did I want to give this talk? And so I'll give you a couple reasons that kind of inspired me to think about these topics. One is my own personal journey. So when I started learning Python, only wrote Python scripts. So Python files. I was working mostly on web application development, but then I got really interested in machine learning, mostly through the Fast AI courses. And so then all my development on that kind of stuff that I was learning was all in notebooks. And so, for some amount of time, I was writing Python professionally, learning machine learning, writing notebooks 100% on the side. And so I obviously had some insight into the differences in these workflows, and this notebook tool that was something I hadn't encountered maybe in my first year or year and a half of writing Python. Now in my job, I work on machine learning. I find myself with a little bit in both worlds, sometimes writing Python for web services, sometimes working with notebooks that data scientists have written. And so that kind of inspired me to think more about this and want to dive in. Also, like a lot of things I do in programming, this was inspired by me going through my Twitter feed one day, and I came upon this tweet by the founder of Fast AI, and he said, "I do think Mathematica doesn't get the credit it deserves for pioneering notebooks." And there's also this whole comment from the creator of Sage, which is another thing I'll talk about later in the talk. And so this also got me thinking, and I was like, I don't know where this tool came from at all. I don't know how we came to the point where people wanted to put code and text and visualizations all together. And so I thought it would be a cool thing to learn more about. And then probably the final reason is that Jupyter notebooks are experiencing some amount of mainstream popularity. You can see there's this article from 2018 from The Atlantic. There's also an article in Nature. And so there's this increased visibility. The Atlantic even going so far to say the scientific paper is obsolete. And so in science, people are only going to be using these kinds of notebooks. And so that is just one more reason I thought it would be both interesting and timely to try to understand a little bit more about where this tool comes from. And so I've structured this talk into three sections, basically past, present, and future. I'll spend most of the time talking about the past. So this is a brief history of Jupyter Notebook. So understanding what were the projects that preceded it, and what are some of the ideas that were kind of in the air when this project came to be, and where did it come from. I'll spend some time going over the present state and some projects that I think are pretty cool. And then I'll spend a little bit of time at the end speculating on what the future might be, and maybe some interesting work that people are doing that hasn't fully hit the mainstream. So I also want to start out by saying what this talk is not about, because I think it's important to establish that at the beginning. So this isn't going to be about how to use Jupyter Notebooks. So I gave a brief demo at the beginning just to give us kind of a common understanding of what the tool looks like, some of the things it can do. But there are some good introductory materials online. There's this article from Real Python. So if you search for that material, it's out there. And I hope the talk maybe inspires you to even want to look into this a little bit more if you haven't already. This is also not about loving or hating Jupyter Notebooks. There's good material on that already. This is a pretty well-known talk by Joel Gruss, where he went to JupyterCon and gave a talk called "I Don't Like Notebooks," which is very entertaining. I would definitely encourage you to look up that talk, but that's not what this is going to be about. And then that spawned kind of a whole backlash and defense. And so if you search the first notebook war, you're going to find some of these talks and blog posts that go into what's great about it, what sucks about it, people talking about that. But that's not what I'm going to cover today. Today is a more of a historical look at it. And like I said, trying to understand the origins of how we came to write code in this way, hopefully to give us a better understanding of the tools, the directions they may go in, and hopefully also in light of some of these wars, a little more empathy for people both who choose to use these tools as well as those who choose not to. So we'll start with the past, and we're going to go back in time. I have to apologize to all the former science PhDs out there. I know that is a common path into data science, and you may have even chosen that path to get away from some of these tools that I'm about to talk about. But that's just a heads up that you're going to see some of these interfaces that you may have been able to avoid over the last couple of years. So this goes back to this guy. And who's this guy? People might know him as the guy who helped you with your math homework through the Wolfram Alpha interface. So this is Stephen Wolfram. And the story that's going to lead us eventually to the Jupyter Notebook starts with Stephen Wolfram and Mathematica, which came out in 1988. So Mathematica is kind of this all-in-one system. It has a language, which is called Wolfram. Funny enough, it's an execution environment, a lot of scientific and numerical libraries packaged into this system. And also, important for our story, a notebook interface, which was designed by this man, Theodore Gray. And Mathematica was very well received at the time. It won a Byte Award, the first annual Byte Awards, and it was praised for helping students with various mathematical and scientific tasks. The interesting thing about this is I was able actually to go through this magazine, and I think I pulled out a couple of things that established kind of the time frame that we're in. Some of the other things that won the first annual Byte Awards. So we have Next Computer, and an interesting anecdote here is Steve Jobs is actually the one who convinced Wolfram to name the system Mathematica. So that's a little tidbit. You might recognize this, maybe. This HP DeskJet printer, that was state of the art back in 1988. And also this book, the second edition of Advanced MS-DOS Programming. So this is kind of the computing environment that we were in, and Mathematica comes out. So there's some key architectural details of the Mathematica notebooks that become important to the further development of these notebook interfaces. There's two parts to the system. So there's the kernel, which is going to actually execute the code and return the results back, as well as a front-end interface, which presents what is the notebook. Another kind of interesting and important part is the Mathematica notebook itself could be manipulated by Mathematica programs. So there is that kind of element to it as well. So this was kind of the foundational ideas behind Mathematica notebooks when they came out. And just to give you an idea of what it looked like back in 1988, and I actually found these in the Mathematica scrapbook when I was researching this talk, and it was fascinating to me. So here's one example. So you can see that my math is very rusty, but this is doing some kind of series expansion. I also don't know Mathematica. So, but the interesting thing to me is just how the interface looks. And it's kind of established this pattern that if you've used Jupyter Notebooks, might actually look familiar to you, even though it's from like many decades ago. So you have this code that executes in the input, and the output is this expanded result. Even more interesting is this visualization, which is really cool. So this is it actually doing a 3D plot and returning that output. So these are things from way back in the day, but I think it's really cool to look at them and see how this same functionality kind of lives on even to the present. But actually, the story doesn't really start with Mathematica. In order to understand the ideas behind notebook interfaces, we have to go even further back to the guy who you might know as the author of books that everybody tells you they've read, but probably haven't actually read. So this is Donald Knuth. He's done a lot of things in computer science. And one of the things that he did that's maybe not as well known, at least not as well known as the books and as LaTeX, is these ideas of literate programming. So he had this idea that we could write code and text together. And he implemented this in a system that he called Web, which maybe not the greatest name. You know what they say about kind of naming things. So he had this system called Web. And the idea was that these text and code snippets would be tangled together. And so you could be writing text and code, and the text would help you understand the code, and it would all flow together. And then some of the benefits of the system is you could then pull out the text, for example, and weave that together into a kind of documentation. But you'd also be able to execute the code snippets that were embedded in it. And this is a really important idea. It's kind of foundational to a lot of the work that happened later on notebook interfaces in the Jupyter Notebook. So this is just an important thing to keep in mind, is that literate programming is this idea that comes even further back than when these interfaces like Mathematica started coming out. So the next tool that we should talk about kind of in the progression of the notebook interface. So Maple, like Mathematica, was kind of this scientific computing environment, as well as its own programming language. Sorry about that. And the first GUI for Maple came out in 1989. So that's after Mathematica. And then in 1992, it came up with this worksheet interface, which again, kind of anticipates the familiar notebook interface. So this is from the release notes. The user interface will support the concept of a worksheet, so you can integrate text, Maple input commands, Maple output, as well as graphics all in one. So again, you can see how even, say, back in the late 80s, early 90s, there are these ideas and these tools that are letting you do this kind of thing with code and text and visualization. So here's kind of a picture of what the Maple interface looked like. So you can see, again, you can execute addition. You can also do these mathematical operations like factorization. You can call into help and other things. And here's another example where you can actually do a 3D plot. And so this is an application that's running on your computer that lets you do this 3D plotting, but also includes the code that actually generated the plot. So this is pretty cool stuff that was happening even in the 90s. And I think it's also interesting to look at the differences, say, between Mathematica and then Maple, which came out again a couple of years later. And I will say these are from a Maple document, but I think it's interesting because they kind of present them as clear advantages, but I think you can consider them just as trade-offs when you're designing this kind of system. So one thing Maple really highlighted is it's using standard math notation. So on the left side, those look more like math expressions. The interesting thing is, to me, the Mathematica looks a lot more like kind of what programmers would write. So you see things like the double equals, the function naming obviously looks a little bit more like an actual program. So this is one of the differences that started to come out between these tools, is saying the code to write the program versus the code that's supposed to look like actual math, maybe that people would have in their papers. So that's just one thing. Another thing that was interesting in Maple is that you can actually re-execute the the stuff that's embedded in the text. So you can see in this example here, you've embedded a function and it's evaluated it to find this discontinuity. But if you actually change the function, it will also update the text statement in this document. So I thought that was another pretty cool feature of Maple. And this one I think is just an entertaining one that I found when I was digging into this. So uh, this is the enter versus shift enter. So Mathematica is who you have to thank maybe if you're a person who does shift enter a lot in the Jupyter notebook. But Maple was pushing very hard to say this is a non-standard interaction that requires the users to adapt their normal behavior. Although now I think most users of notebooks are pretty familiar with it. But there was a downside to these tools, which is cost. So it costs a lot to license Mathematica. It costs a lot to license Maple. I mean, these are the current prices for personal licenses, but basically people didn't necessarily want to pay for the use of these tools. And so this is where the history of the notebook kind of coincides with the rise of open source. And this is also where we start to see it meeting with Python. So in the early 2000s, there was really this confluence of several tools that came out that are going to spark a lot of the development that happened later. So you have SciPy, which combined several kind of in progress scientific numerical libraries for Python. Then IPython, and this is IPython before the notebook. So there was later an IPython notebook, but this was IPython, like the terminal and some of these features around parallel computation. So the IPython was an improvement on the Python environment even before they introduced the IPython notebook. And then finally, Matplotlib. And this was an interesting anecdote. Another thing I found when I was researching this talk is it was originally actually conceived as a patch to the IPython tool. So it was going to enable plotting in IPython. But the creator of IPython, Fernando Perez, did not have time to look at the patch, and so it became its own library, a library that a lot of people still use today. So that was an interesting thing. But you can really look at the release of these three libraries, as well as several other related ones, as the growth of these open source scientific tools, and that's really going to push toward the development of later notebook interfaces that we're going to talk about. So I did want to spend one slide talking about Fernando Perez because the story of the Jupyter Notebook cannot be told without him. He is someone who is largely responsible for it. So he created IPython in 2001 as a graduate student. He's currently an associate professor at Berkeley, as well as a co-founder and senior fellow at the Berkeley Institute for Data Science. Still doing a lot of work on Python and Python tooling, and he's also received several awards for his work on this software. So he's someone who really drove the development of the IPython notebook and Jupyter notebook later forward. So with the development of these open source Python tools, I think people started to think, how can we actually use these libraries also in an environment that gives us the benefits of something like Mathematica or Maple? And so that's when Sage or Sage Math came out in 2005. So this was an open source software system, and you can see it right in the documentation. They say a viable open source alternative to Magma, Maple, Mathematica, and MATLAB. So it's integrating these open source Python tools into an execution environment and a web-based notebook. So this was created by William Stein, and it was implemented in Python and Python. And like I said, importantly, it was released with an open source license. So this was a really big step in the development of notebooks and in their increased adoption. So it was kind of hard to find some examples of the interface because you can actually now execute Sage kernels in Jupyter. So there's kind of been a confluence there. But this is from a tutorial circa 2012 that gives you some idea of what the Sage notebook and the files are called worksheets. This is kind of what it looked like back then, at least. And you can see it can also do basic, code execution and math. The very interesting thing to me that Sage had that you don't necessarily even see in tools today is it actually embedded word editing into the notebook. So you can see this. This is like a full featured word editor in the Sage notebook system, which I think is pretty cool. And maybe something that actually could be done in Jupyter today, or maybe someone's developed the package and I just haven't seen it. But if not, that's a open source opportunity there. The other thing I saw in the Sage documentation I just wanted to highlight is the Shift Enter continued to be the dominant mode, and Maple wanting to just let users hit Enter, that never really caught on. So that's why you're stuck with Shift Enter all the way through your notebook. So finally, we get to what is the precursor to the Jupyter Notebook, the IPython notebook. Again, it's actually kind of hard to find documentation about this because eventually it became Jupyter. But you can see at the time it was embedded into IPython. So you ran IPython notebook, it would open up the interface. And this is from some of the old documentation. And you can see even when it was just IPython notebook, it had these main components. So the web application that would let you combine text and math and code and visualization, as well as the notebook documents that would actually hold on to the information that you've created. And so finally, Project Jupyter. And before I fill in some details here, I want to tell you something that absolutely blew my mind when I found it out, which is, why is it called Jupyter? It's because originally it supported Julia and Python and R, so Jupyter. And I found that out when I was working on this talk, and I thought it was absolutely amazing. So that's kind of where Jupyter comes in. It's kind of a spin-off of IPython and the IPython notebook. Basically, the notebook interface as well as language agnostic parts of IPython. And again, this was formed by Fernando Perez, who had originally created IPython to focus on developing the notebook and other parts outside of IPython. So that brings us all the way up to the present. So I'm going to spend some time going over, I think, projects that are pretty well adopted in the Jupyter ecosystem today. There's obviously the Jupyter Notebook, tried and true. People love it or hate it. So we have the Jupyter Notebook. Also, more recent, Jupyter Lab. So this is the so-called next generation notebook interface. It integrates more kind of IDE type features as opposed to kind of just your standard notebook. So this is something that has come out and is starting to gain popularity as well. So this is kind of what it looks like. You can see the main notebooks in the middle, but it also gives you the file system on the left and some of these other tabs and things that make it look a little bit more like IDEs. Voila. So this is another cool thing, basically a way to turn the Jupyter Notebook into a web application. So basically you can create interactive widgets in the notebook and then hide some of the cells. And so this is one example from their documentation. Basically, you can create these sliders in a Jupyter Notebook and then deploy it. So that's another thing that's kind of become popular. Binder kind of goes along with that. So Binder is an easy way to actually deploy interactive notebooks. So you take a Git repo, give it the name of the repo, and then Binder will actually open this up in an environment that lets you execute it. So this is another tool that has become very useful in the Jupyter ecosystem. The other big thing that characterizes kind of the current state of Jupyter, there are now dozens of languages supported. So kind of when it broke off from IPython, there was the IPython kernel and there was Jupyter, and maybe Julia and R support as well, kind of the main languages of data science. But now there's dozens of languages supported. There's a huge list. You can see in this logo, JavaScript is on there. So another shout out to JavaScript, PHP, F#. And it's actually interesting to me, I went through this list and there's actually some tools that even came up earlier in the history of the notebook interface that now you can actually run through Jupyter. So Sage Math, you can execute as well as actually the Wolfram language for Jupyter, which is a way to let you run Wolfram in Jupyter. So the same language you would use in Mathematica. So that's a big part of Jupyter today, I think, is just this increased access to different languages. Another thing that's really, I think, quite popular, especially among people doing machine learning, is Google Colab. So this is a notebook interface that Google hosts. Has access to Google Drive. It has access to GPUs and TPUs. And so this has become a very popular way to share code and execute code in the browser. Another thing that's really useful is support in GitHub for rendering notebooks. So because it's a lot better to review that than this. So GitHub has support for looking at notebooks, and that's just a really nice thing in a lot of people's workflow. So those are kind of some things that I would say are nice about the present ecosystem. So finally, I'm going to take the opportunity to speculate a little bit about the future, at least based on trends that I'm aware of. So the first thing I think is interesting is kind of a converging of Jupyter and IDEs. So I talked about Jupyter Lab. Jupyter Lab 2.0 actually came out in April of 2020. It adds a lot more features, including the Jupyter Lab language server protocol, which will help support a lot of IDE-like features, as well as a debugger. So you could use PDB before, but this is a more integrated debugger for Jupyter Lab. At the same time, if you look at recent releases of VS Code, they're improving native support for Jupyter notebooks. So at the same time, Jupyter interface is trying to add more IDE-like features. VS Code is trying to add better support for Jupyter. And so I think in the future, this is something that will just continue. Is people don't necessarily want to choose one or the other. Sometimes they want both, or at least the advantages of both. And so I think you're just going to see an increased convergence there. The other thing, and I talked about Colab, is hosted solutions or notebooks as an interface to compute. So this is not a new concept. I mean, you've had Databricks notebooks and other notebooks, but I think it's just something you're going to see more and more of, especially as people start to use more specialized devices for their workflows. So like I said, Colab can connect you to GPUs and TPUs. SageMaker, which is Amazon's ML service, has also become very popular purely for letting you easily set up hosted notebooks that can connect to GPUs. So that's a big feature of SageMaker. And then Kaggle as well allows you to run notebooks that connect to GPUs and TPUs, and also already have access to the data on their competition platform. So increasingly, I think notebooks also become just an interface for running the code that I write on my computer on a computer that is very far away. It becomes a very easy way to do that, and I think you're only going to see more of that as time progresses. The other really interesting thing that people are working on is real-time collaboration. So if the notebook is increasingly the tool of the data scientist, how do we actually let people collaborate on them? And so there's this left side is from a startup called DeepNote, and so they're creating a Jupyter-compatible notebook that allows you to do real-time collaboration. And on the right is from the documentation of CoCalc. So that was actually created by William Stein, who created Sage. And so he's now working on this platform that can allow you to do live collaborative editing and chatting. So a kind of Google Docs-like experience for the Jupyter Notebook. And I think that's something that if someone gets this right, it's going to be absolutely incredible. And I think really things will take off from there if someone can really crack how to get this working. And the last thing, which is something I experience in my work like frequently, is just how to review the notebook and work with Git. And so there's a lot of tools coming out around this. I don't think there's necessarily one that's totally cornered the market. So FastAI has this set of tools called NBDev that they've used to create their library. I think they're incredibly useful if you want to take notebook code and start to turn it into modules and libraries that you can publish and other people can use. It has a lot of great things for that kind of workflow. Review NB is another tool. So you can see a screenshot where it helps. GitHub can render the notebooks, but it still is very bad at diffing. So Review NB is a tool that helps you diff them. And then these are things that literally just came out today. As I was working on this presentation, had to add some slides. So this is GitHub Code Spaces, which will let you edit Jupyter Notebooks directly on GitHub. So I haven't even had time to play with this myself, but it was coming out today. It looked super cool. And then I thought that was the last thing I'd have to add. And then this came out at 5:49 p.m. and it said, automatically drop links to a Jupyter Notebook with the right dependencies in your PRs with the simple actions workflow. And this is powered by Binder, the tool that I mentioned earlier. And so I think these are really cool things that are just going to improve the review and kind of working with notebooks in Git or some kind of version control system. That really still has a lot of pain points. And so I think tooling around this is really going to be a really big future direction for notebooks. So that concludes my talk. But I did want to say, I love notebooks, but you don't have to love them. I hope at least this talk showed you a little bit about where they came from. They're not just some idea people came up with in the last couple of years to torment software engineers. There really is a rich history behind these tools and the way people use them. And I think there's a lot to be learned from looking at where these came from and also looking into what features they might support in the future. So thank you so much for having me. And yeah, I'm happy to take some questions from the chat.
Awesome. Thanks so much, William. Everybody, can we please give William a round of applause in the chat? I just threw mine in there. I really like the idea of like learning from software history, because a lot of this is context, and like knowing about it explains a lot of decisions. Like the shift enter, that's fascinating. I love that. So while we're waiting for questions to come in, I do have a couple of questions. Like, what is your workflow with Jupyter Notebooks? Like, I know people use them in many different ways, but do you have like a workflow that works for you?
Yeah, I guess I'll talk about two workflows. Like, I'll talk about what I do for, say, like Kaggle competitions, which is I just use notebooks like all the way through. It's just notebooks. I make copies of the notebooks. I edit them. I would not say it's an efficient workflow, but for something like that, like you're trying out a lot of things. So I just kind of work in the notebooks, and but there are some downsides to that. Like I will say, so sorry, I need to get a drink of water. At work, though, I mean, we're working on this because we have engineers as well as scientists. So a lot of the times it comes down to maybe the data scientist has done an exploratory work in a notebook, and often what I find myself having to do is like pull those parts out, turn them into a Python module that we can actually use, say, in like a service or in like a consumer process. So at work, a lot of the times it's figuring out, okay, how do we take this notebook code and then factor out the parts of it into a Python file? So that's to say, I don't think I've totally solved it, like, but I think at least for now, maybe in like a professional setting, often the end goal is always going to be like Python files, with some exceptions. Like Netflix has some tools like Papermill, which I wanted to include. I don't think I had time to throw that slide in there, but they basically just execute notebooks as their workflows. So it's like they can parameterize notebooks. I got to sprint on this at PyCon last year, and it was very fun. So so some people do it, but I think right now, a lot of time the workflow is going to be experimentation and interaction in a Jupyter notebook. And then at some point, I think you're going to have an engineer turn it into Python code that you're going to run.
Yeah, awesome. That makes a lot of sense. Like productionizing things is just a really difficult concept to begin with. Our next question comes from Joe Jasinski, and Joe actually had a presentation or a tutorial at PyCon a couple years ago on using Docker for data science. So putting it behind, like putting an API behind your model or something like that. And so that's like one way of doing it. But for this question, Joe's wondering, how do you distribute notebooks? Let's start with that one.
Yeah, that's a really good question. I mean, I can tell you what my team does. Like sometimes we check them into Git. So like I said, there's some friction around the review process, but at least like then the file is checked in is the one like that you can get and run. But it's also I guess the interesting thing there is like there's always like dead notebooks and there's live notebooks. Like the notebook you commit is just a JSON representation of the notebook that was run. Whereas really what you probably want is to actually like open up the notebook, which is why something like Binder becomes popular. I'll also say like one thing we're doing is having like some kind of centralized Jupyter server. So in our case, we use Kubeflow for machine learning infrastructure. So if you enable people to host Jupyter servers, then sharing the notebook can also just become like sending the link. So like I have access to our Jupyter server, you have access to our Jupyter server. We can send those links around and collaborate. You still run into the problems of things like getting out of sync. So maybe you sent me the link to your notebook yesterday. I wanted to adapt it, and you also did work on it today. So like I said, those things I don't think are even solved. There's just like different workarounds that we're using and that other people are using. But it's a really good question. I wish I had a good answer for it.
Yeah, I think it's just as the space evolves, like better answers come about, better tools come about. Like I remember just a few years ago, like notebook diffing was so difficult, and now it's like sort of like feasible as like
sort
a
of
workflow on a
okay.
team. Yeah,
Yeah.
it's not that bad. And so Joe also had a second question. Do you know of any alternatives to binders?
I'm not that familiar with the alternatives, so unfortunately, I can't help you with that one.
Okay, cool. We have another question. What are some useful Jupyter extensions, and preferably if they're extensions for data scientists?
Yeah, that's a really good question. I think like some of the ones I mentioned in Jupyter Lab 2.0. Well, I guess you asked for data scientists, but I'm excited about some of the language server features. Like I think it's gonna be really cool because that's one thing I miss. Like I work a lot in IntelliJ when I'm actually writing code, and a lot of the things you get from working in code there up to this point haven't been supported. So I personally am very excited about some of those things. The other things I think for data scientists, one that I'm aware of that I also think is super cool is you can actually monitor like GPU usage. So this is something that's come out of NVIDIA, where as you're running your notebook, you can also have this extension that's kind of visualizing how saturated the GPU becomes. And so that can be a really useful part of the workflow if you're doing anything on GPU, which is a lot of it these days. So yeah, those are some things at least that I've seen that I think are pretty cool.
Awesome. And just a shout out for our audience to check out, William has been giving, he gave a talk on GPUs. So if you search William Horton on YouTube, you will find that talk. I highly recommend it. We have a question coming in from Derek. Oh, would you ever want to write a PDF book or an ebook with Jupyter? Has somebody done that yet?
Yeah, that's a really good question. That's another thing that I kind of cut out of the talk for time reasons, but there are a couple libraries. The big one is Jupyter Book. So if that's something you're interested in, I would check it out. And then FastAI's book was also completely generated out of Jupyter notebooks, and they have a very interesting system that they've written for kind of pulling out and annotating different sections that are meant to be rendered in different ways. So I think it's there right now, and I think I've seen like really good results from the people who are using these things. So yeah, I mean that's a great question. It's a really cool use case, and I think the tooling is out there right now.
Yeah, every time I see what Fast AI does with like notebooks, I get a little scared. I'm like, have they gone too far?
Yeah, I think a lot of people ask that, but
it's like you're serving like a blog from a notebook. That's like a little bit crazy, but it's also amazing that you can do that.
Yeah, I think one thing I really like admire from them is they have a philosophy. They get the tools to work for them, right? So some people criticize them for it, but I think Jeremy and the other collaborators, like they're using Python and Jupyter to enable their workflows, right? They're not necessarily so concerned about what is Pythonic or how you should use notebooks. And I respect that a lot. And I mean, I've learned a lot from them, even if like I wouldn't necessarily do everything that they're doing with notebooks. I think it's super cool.
Yeah. Software is about shipping, and you got to respect how much they ship. We got a question from the chat. Do you know of a good tool for word correction in a notebook? Like maybe like a spell check or a grammar check?
I'm not really aware of that. Sorry.
Cool. That's okay. I'm sure there's something. I know Jupyter, if you go to their website, they have a huge list of plugins. So that's definitely an avenue people can find to get things that they're looking for. Before we let you go, do you have any call to actions for our community?
Ooh, I didn't know I was going to be asked for that.
Sorry to put you on the spot. Besides play animal, is it animal play? What is it?
Animal.
I don't even know this.
Play Animal Crossing.
Animal Crossing, yeah. Play more Animal Crossing.
Yeah, just have fun. I think being quarantined is some opportunity to learn new things, and it doesn't have to be technical things, right? So it's fun to learn about some of this stuff and write code, and I spend some of my personal time on that. But it's just a good time to spend on whatever makes you happy. I think that's really key.
That's solid advice. Focus on yourself. That's where happiness comes from. Well, William, it was great having you on. Thanks so much for joining us.
Yeah, thank you so much for having me.